Hello friends, in today's video we are solving one chemistry paper, paper 4 062041 May June 2020. Let's start with our first question. The question is about elements X, Y and Z. Sub question A. An atom of element X is represented as 3416X. It means mass number is 34 and atomic number is 16. Question A1. Name the different types of particles found in the nucleus of this atom of X. Particles found in the nucleus are protons and neutrons. Question A2. What is the term for total number of particles in the nucleus of an atom? Term for total number of particles in the nucleus of an atom is nucleons. Question A3. What is the total number of particles in the nucleus of an atom? 3416X. Particles present in the nucleus are protons and neutrons. Mass number is sum of protons and neutrons present in the nucleus. To answer to the question, total number of particles in the nucleus of an atom is same as mass number, which is 34. Question A4. What is the electronic structure of ion X-2? Let us first write electronic configuration of atom X. Atomic number is 16, so electronic configuration is 286. But electronic configuration of ion X-2. -2 indicates that it has accepted 2 electrons. So electronic configuration will be 288. Question A5. Suggest the formula of a compound formed between aluminium and X. Valency of aluminium is +3, or it has 3 electrons in the outermost shell, whereas X requires 2 electrons. To find the formula of the compound, we will interchange valencies. So the formula of compound form will be Al2X3. Next question is B1. What term is used to describe atoms of the same element with different numbers of particles in the nucleus? The term used to describe atoms of the same element with different number of particles in the nucleus is isotopes. Isotopes have same number of protons in the nucleus, but number of neutrons is different. Question B2. Identify the atom against which relative masses of all other atoms are compared. RAM of all atoms is compared to carbon atom, that is 12C. Question B3. What is the name of the amount of any substance that contains 6.02 into 10 raised to 23 particles? And the answer is a mole or 1 mole. 1 mole contains 6.02 into 10 raised to 23 particles of any substance. Question B4. The constant 6.02 into 10 to the power 23 has a name. What is the name of this constant? The name is Avogadro constant. Sub-question C. Part of the definition of relative atomic mass is the average mass of naturally occurring atoms of an element. Some relative atomic masses are not whole numbers. Element Y has only two different types of atoms, 69Y and 71Y. The ratio of atoms present in element Y is shown. 69Y s to 71Y is equals to 3 s to 2. Calculate the relative atomic mass of element Y to 1 decimal place. To calculate RAM of element Y, we have to take into consideration percentage of each isotope present naturally. But here we are given ratio of isotopes, which is 3:2. That means out of total 5 parts, 3 parts is isotope 69Y and 2 parts 71Y. So RAM of Y will be 69 into 3 parts plus 71 into 2 parts divided by total parts, that is 5. This on calculation comes to 69.8. So relative atomic mass of element Y is 69.8. Next, we are asked to identify element Y. It is gallium. Sub-question D. Element Z is in period 3 and group 5. Identify element Z. Let us try to locate it in periodic table. element belonging to period 3 and group 5 is phosphorus. Question D2. Explain in terms of electron transfer why Z behaves chemically as a non-metal. Element Z of phosphorus has atomic number 15. So its electronic configuration is 285. That means it has 5 electrons in the outermost shell. To form iron, it will accept 3 electrons. So element Z behaves chemically as a non-metal as it accepts 3 electrons to form iron. Our first question is done. Now second one. Second question is magnesium is a metal. Name and describe the bonding in magnesium. The type of bonding in magnesium or metals is metallic bonding. In second part of the question, we are asked to describe the bonding. In magnesium of metals, outer electrons are delocalized or free to move. Or we can say there is a sea of electrons and there is a strong electrostatic force of attraction between positively charged metal ions and delocalized negative electrons. This is metallic bonding. B part of the question. Magnesium oxide MgO is formed when magnesium burns in oxygen. Complete the dot and cross diagram to show electron arrangement of ions in magnesium oxide. Inner shells have been drawn. Give the charges on the ions. Let us first write down electronic configuration of magnesium atom and oxygen atom, and also when they become ions, that is after giving and taking electrons. Magnesium atom has atomic number 12, so electronic configuration is 282, and oxygen atom atomic number 8 has electronic configuration 26. So magnesium has 2 extra electrons in the outermost shell and oxygen needs 2 electrons to complete its octet. Magnesium atom gives away 2 electrons to oxygen atom and becomes magnesium ion with electronic configuration 28. That is Mg plus 2 ion or cation is formed. And oxygen atom takes 2 electrons from magnesium and becomes oxygen ion or oxygen anion with electronic configuration 28. In our diagram, dots represent electrons from magnesium and crosses represent electrons from oxygen. We can see outer shell of oxygen ion has 6 crosses and 2 dots. 2 dots represent electrons from magnesium. We have completed dot and cross diagram and we have also given charges on the ions. So let's move on to question B2. Write chemical equation for the reaction that occurs when magnesium burns in oxygen. And the equation is Mg plus O2 gives MgO. Let us balance it. Magnesium is same on both sides. Oxygen is unequal. So to equalize it, we'll write 2 as a coefficient of product MgO. But then magnesium becomes unequal. To equalize that, we write 2 as a coefficient of magnesium. The equation is now balanced. Our next question is question 2c. Magnesium oxide also forms when magnesium nitrate MgNO32 is heated strongly. This is an endothermic reaction. Question C1. Write the chemical equation for this reaction. And the equation is MgNO32 gives MgO plus NO2 plus oxygen. This equation is not balanced, so let us balance it. There is one magnesium atom on both sides, that is reactant side and product side. Let us balance oxygen. Oxygen is 3 2s are 6 on reactant side and on product side it is 5. So we will make it even number by writing 2 as a coefficient of MgO. That disturbs balance of Mg. So we will write 2 as a coefficient of magnesium nitrate to balance it. Now let us check how many nitrates are there. We have 4 nitrate radicals on reactant side. So 4 molecules of NO2 will be produced. So we write 4 as a coefficient of NO2. Now the equation is balanced. Question C2. What type of reaction is this? Since magnesium nitrate is heated strongly and it decomposes, So the type of reaction is thermal decomposition reaction. Next is C3. Name two other compounds of magnesium that form magnesium oxide when heated. And the compounds are magnesium carbonate and magnesium hydroxide. Let us start question 3a. Sulfur dioxide is used in the manufacture of sulfuric acid. Question 3a is, in first stage of the process, sulfur dioxide is obtained from sulfur containing ores. Name one of these ores. And the answer is zinc blende, ZNS. Question 3b. The next stage of the process is a reaction which can reach equilibrium. The equation for this stage is shown. Two molecules of sulfur dioxide gas react with oxygen gas to form two molecules of sulfur trioxide gas. Describe two features of an equilibrium. And the two features are, first, the reaction is reversible. Second, the rate of forward reaction is equal to rate of reverse reaction. Question B2. Name the catalyst used in this stage. And the catalyst is vanadium pentoxide. Question B3. Why is catalyst used? Catalyst increases the rate of reaction. Fourth sub-question. Explain in terms of particles why a high temperature increases the rate of this reaction. Increase in temperature results in particles having more energy, move more quickly. Second, frequency of successful collisions increases and the rate of reaction increases. Sub-question 5. In this stage, only a moderate temperature of 450 degrees Celsius is used. What does this suggest about the forward reaction? Use of moderate temperature in this stage indicates that the reaction is exothermic. Endothermic reaction is favored by high temperature. Sub-question 6. Calculate the percentage by mass of sulfur in sulfur trioxide. Sulfur trioxide has 1 atom of sulfur and 3 atoms of oxygen. So Mr of SO3 is atomic weight of sulfur plus 3 into atomic weight of oxygen, that is 32 plus 3 into 16, which comes to 80. Therefore, percentage of sulfur in SO3 is 32 by 80 into 100, which comes to 40%. So percentage of sulfur in sulfur trioxide is 40%. Sub-question C. Concentrated sulfuric acid is a dehydrating agent which can chemically remove water from substances. Both hydrated copper-2 sulfate crystals and sucrose, a sugar, C12H22O11, can be completely dehydrated by concentrated sulfuric acid. Name the solid product formed in each case. Concentrated sulfuric acid removes the water of crystallization from hydrated copper sulfate, which is blue in color, and turns it into anhydrous copper sulfate, which is white in color. And on reaction with sucrose, C12H22O11, concentrated sulfuric acid removes the water molecule from the molecule of sucrose itself and turns it into carbon. Sub-question D. When propan-1-ol is heated with concentrated sulfuric acid as a catalyst, an unsaturated hydrocarbon of a relative molecular mass 42 is formed, and one other product. First sub-question. What is meant by the term unsaturated? The term unsaturated means that not all carbon-carbon bonds are single. It means it has one or more double or triple bonds between carbon and carbon atoms. Question D2. Write the chemical equation for this reaction. And the reaction is propan-1-ol, that is C3H7O6, in presence of concentrated sulfuric acid as a catalyst, forms C3H6 plus water. Next is question D3. Name the unsaturated hydrocarbon formed. And the answer is propene. Propene is the unsaturated hydrocarbon formed as it contains C double bond C in it. Our next question is question 4. The question is about reaction of bases and acids. Question 4a. Ammonia is a gas at room temperature. What is the test for ammonia gas? Describe the positive result of this test. And the test is damp red litmus paper test. And the result is it turns blue. Let's see what we have in 4b. Ammonia reacts with water to form ions. We are given reaction of ammonia gas with water in which ammonium ion is formed and hydroxyl ion is formed. How does the equation show that ammonia NH3 behaves as a base? In this reaction, ammonia acts as a proton acceptor. It accepts a proton and forms ammonium ion. So it behaves as a base. Next question B2. Aqueous ammonia is described as a weak base. Suggest the pH of aqueous ammonia. Since aqueous ammonia is a weak base, its pH value will be above 7 and below 11. We will give it a specific value of 9 pH. Next question, question B3. Describe what is seen when aqueous ammonia is added to aqueous copper 2 sulfate until no further change is seen. When aqueous ammonia is added to copper 2 sulfate, blue precipitate of copper hydroxide is formed. The precipitate dissolves on further addition of aqueous ammonia and blue solution remains. Sub-question C. Aqueous sodium hydroxide NaOH is a strong alkali that reacts with dilute sulfuric acid exothermically. First sub-question. What type of reaction is this? Since the reaction is between acid and alkali, it is neutralization reaction. Question C2. Complete the equation for the reaction between aqueous sodium hydroxide and dilute sulfuric acid. Since the reaction is neutralization reaction between acid and base, salt and water is formed. Salt is Na2SO4 and water. Question 4D. A student wanted to find the concentration of some dilute sulfuric acid by titration. The student found that 25 cm cube of 0.0400 mole per dm cube of aqueous NaOH reacted exactly with 20 cm cube of H2SO4 aqueous. Question 1. Name a suitable indicator to use in this titration. And the answer is methyl orange. Question D2. Calculate the concentration of H2SO4 in mole per dm cube using following steps. First, calculate the number of moles of NaOH in 25 cm cube. Formula which we are using to calculate number of moles is equals to concentration in mole per dm cube into volume in dm cube. The volume given is in centimeter cube, so we are dividing it by 1000 to change it into dm cube. So we have mole of NaOH is equals to 0.0400 into 25 by 1000, and this on calculation comes to 0.001 mole. In the next step, we are asked to deduce the number of moles of H2SO4 that reacted with 25 centimeter cube of NaOH. Let us first write equation of this titration. And the equation is H2SO4 plus NaOH gives Na2SO4 plus water. Let us balance this equation. We have two atoms of sodium on right side and one on left side. So we will write 2 as a coefficient of NaOH. So now we have 2 Na and 1 SO4 on either side of the equation. To balance hydrogen and oxygen, we write 2 as a coefficient of water. From equation we can see 2 moles of NaOH require 1 mole of H2SO4. So mole of H2SO4 is equals to half the mole of NaOH, that is 0.001 divided by 2, which on calculation comes to 0.0005. In the next step, we are asked to calculate the concentration of H2SO4 in mole per dm cube. The concentration which we got in the previous step, that is 0.0005, that is present in 20 centimeter cube of H2SO4. To make it into dm cube, we will multiply this by 1000 and divide by 20. So this on calculation comes to 0.025 mole per dm cube. Question D3. Calculate the concentration of the 0.0400 mole per dm cube of NaOH in gram per dm cube. To find concentration in gram per dm cube, we have to multiply concentration in mole per dm cube by relative molecular mass. So molecular mass of NaOH is 40. We'll multiply 0.0400 into 40, which on calculation comes to 1.6. So concentration is 1.6 gram per dm cube. Let's see what we have in question number 5. Ethanol is manufactured by two different processes. 5a. For each process, name the organic reactant and state the type of reaction. First, organic reactant sugar, type of reaction fermentation. Next, organic reactant ethene, type of reaction hydration. Question 5b. Alcohols can be oxidized to form carboxylic acids. Name a suitable oxidizing agent for this reaction. And the answer is acidified potassium manganate 7. Question 5c. Alcohols can be partially oxidized to form aldehydes. Aldehydes are a homologous series of organic compounds. Partial oxidation is achieved by reacting an alcohol with oxidizing agent in a distillation apparatus as shown. Question C1. Name the apparatus A. And the answer is apparatus A is Liebig condenser. Question C2. On the diagram, use one arrow to show where the water enters apparatus A. Water enters apparatus A from the lower end, that is near the beaker where distillate is being formed after condensation. Question 5D. The table shows some information about aldehydes. D1. Complete the table. A table is given with one name and one molecular formula missing, which we have to fill. First molecular formula shows CH2O. It has one carbon, so name of aldehyde will be methanol. Next two formula and names are given: ethanol C2H4O, propanol C3H6O. So butanol will be C4H8O. Question D2. Deduce the general formula of aldehydes. General formula of aldehydes will be CnH2nO. Next one is question 5e. The structural formula of ethanol is shown. The CO group in aldehyde is at the end of carbon chain. This is a reactive part of the molecule. What is the name given to reactive part of any organic molecule? Reactive part is termed as functional group. Question E2. Complete a dot and cross diagram to show electron arrangement of a molecule of ethanol. Inner shells have been drawn. Let us first draw branch diagram of ethanol to understand which bonds are to be formed. The carbon atom on the left side has 3 covalent bonds with hydrogen atom and 1 covalent bond with the next carbon atom. So these are a pair of electrons to represent 4 covalent bonds. Now about 4 bonds of carbon on the right hand side. One we have already shown with the other carbon atom. One with hydrogen is this one, and 2 covalent bonds with oxygen atoms are shown by dots and crosses. In this diagram, all valencies of hydrogen and carbon are filled by formation of covalent bonds. But oxygen has 6 electrons in the outermost shell and it has utilized 2 electrons by forming double bond with carbon. But 2 pairs of electrons are still remaining in the outer shell. These are 2 lone pair of electrons on oxygen atom. Sub question F. Propanol belongs to homologous series called ketones. Ketones have same C double bond O group as aldehydes, but C double bond O group is not at the end of the carbon chain. Propanol has the same molecular formula as propanol C3H6O. First question. What term is used to describe molecules with different structures but with same molecular formula? And the answer is structural isomers. Question F2. Suggest the structure of propanol C3H6O. Show all of the atoms and all of the bonds. Things to be kept in mind while drawing this: propanol will have 3 carbons and carbonyl group C double bond O group will be in the middle, not at the end. Each carbon atom will form 4 covalent bonds.